All right, so let's talk about how to find the domain and range of a polynomial. I have the generic way that you can write a polynomial, a sub n times x to the power of n plus a sub n minus 1 times x to the n to the power of n minus 1 plus, and we keep going all the way down till we get to a sub 1 times x plus a naught, which is just a constant. Okay, so you're not used to seeing it written this way, but I'm going to do it pretty generically. So let's talk about the domain of a polynomial. Well, the domain of any polynomial is going to be the set of all real numbers. So the domain of any polynomial is going to be the set of all x's such that x is an element of the real numbers, and this is in set notation. If I wanted an interval notation, we're going to go from negative infinity to infinity. All right. Now the range is a way more complex to find. If you have a graph, it's a lot easier to find it because you just look for the lowest y value and the highest y value, or if you see if the arrows are going up or down and if any y values are skipped. But if you have to do it analytically, it's significantly harder, so you have to be careful doing it. So you kind of have to think of what this graph actually is doing and what it looks like. So the easiest way that I find to find the domain is I think of end behavior on this graph of the polynomial. So there's a couple of different rules we can do. You're going to need to know two things. You're going to need to know what's your leading coefficient. So I'm going to work an example here. So we say we have negative 7x squared plus 3x minus 4. This is a polynomial. In fact, it's a quadratic that you're familiar to seeing. Now, I'm using this to find the degree of the polynomial and the leading coefficient because those are the two things you're going to need to figure out the end behavior. My leading coefficient is always the number and sign, just remember the number and sign in front of the x with the highest exponent. So my leading coefficient, I'm not going to keep spelling it out. I'm going to call this LC for the rest of this video. But my leading coefficient in this case, I'm going to look to see where's my highest exponent. Well, my highest exponent is right here on the square. So I'm going to go to the number and sign directly in front of it. So my leading coefficient is the number and sign directly in front of the x that has the highest exponent on there. So my leading coefficient in this case is negative 7, but I don't really care about the number. I care more about the sign, and you'll see that in a second. Then I need to figure out what is the degree. Well, the degree is really hard to figure out. Not really. Use just your highest exponent. So you're going to look at all your exponents, you're going to take the highest number. Well, if you already found the leading coefficient, well, you've already found the highest exponent. My highest exponent is 2. It's my greatest exponent. So the degree of this polynomial is 2. But I don't care about the number. I care if it's going to be an even number or an odd, and 2 is even. Well, when I look at this, what this actually tells me, if I would just had to have graphed this, and you would know this from a parabola, because my leading coefficient is negative and it's even, it's going down. And if we were to put this in vertex form, you would indeed see that this parabola is it's opening downward. All right, so there's some set rules here that we need to know. There's 4 rules. We need to look at my leading coefficient. We need to look at my degree. I'm going to call that, well, I'll just spell it out, my degree. And this is what it's doing at the end. Now, this is just rough. What's not rough, this is just going to give you a visual of what the graph's doing. Later on, we're going to actually I'm going to make you write this with proper notation. So this is end behavior. But it's not what proper notation. It's just to give you an idea of what the graph's doing. I think I misspelled end behavior. So the first thing I need to think about, is my leading coefficient positive? So positive. I could write this all fancy math, and I can say, like, if a sub n is greater than 0, because any number greater than 0 is positive, and you can see a sub n has got to be in my highest exponent because everything else you're subtracting 1 from. So this is the fancy math, but all that means is it positive? And if my degree is even, even, well, the best way to think about that is x squared, and that's like this. So the end behavior of my graph is going like this. Well, what if my leading coefficient is negative? Well, that's the one we did here. And I can make this fancy by saying a sub n is less than 0 because everything less than 0 is a negative number. A sub n is my leading coefficient. And if this is if my degree is, again, even. Well, in this case, it's going down, which is what we had in this little example, finding my leading coefficients and my degree. All right, so these are the two you have to be careful with when you're finding your range. Be careful. That one is going to be a little, you're going to have to look in, you're going to have to do transformations, you're going to have to find the highest or lowest y value. We're not going to get too very much involved in this until later on in the year, but right now I'm just doing a quadratic with some basic transformations. All right, the other two scenarios. Let's put them over here. Same thing. If I have a positive leading coefficient, which is going to be my a sub n is greater than 0. That's just fancy, but you just think in terms of positive, leading coefficient being positive, and it's odd. Well, you know this one is x cubed. Well, that graph's going to go down and then up. And then if I have negative, which is going to be my a sub n is less than 0, and this is odd, well, these just flip. These right here, my range is going to be the set of all y such that y is an element of the real numbers, or in interval notation, negative infinity to infinity. This is the only one you have to be careful with. If your degree is even, you're going to have to be careful. You're going to have to look and see, hey, did the graph move up? Did it move down? Did it go up? To actually figure out your highest and lowest y value, because it could be several different things. In the next couple of videos, I show you examples of these, of this one. Everything else, when you deal with the polynomial, the domain is always a set of all real numbers. If you have an odd degree, your range is always a set of real numbers, unless otherwise stated. But if we're just dealing with generic polynomials, that's going to be a hard, fast rule. This one is the one you have to be careful with.